Assumption matter. So one thing that we had with the basic law of the basic limit laws that we discussed in this section. By the way, we're doing section 2.3. One thing that we had was there was always assumptions. With product law, we had two limits have to exist. With the quotient law, two limits have to exist, and the denominator has to be non-zero. And we saw the limits of the denominator has to be non-zero, and we saw that it would not work if those values are not basically and accordingly, or the existence are not satisfied, and so either of the limits existence is not satisfied, then the laws will not apply. So let's think about an example. The product law cannot be applied to the limit of f of x times g of x if f of x is equal to x and g of x equal to x, the reciprocal of x, 1 over x. Because if I apply the product law, what do I get? I get limit of f of x as x approaches 0 times limit of g of x as x approaches 0, and the second one doesn't exist, so the entire limit should not exist. But that's not how things work, basically, and we have to be very careful as we progress that if we're separating the limits by any of the basic laws, both limits have to exist, otherwise it's not going to work, basically. And so in here, again, because it's not satisfied, we cannot use product law. But notice, if f of g times g of x is going to be 1, so the limit of the product is always 1. It's just that the domain is not including x. The product, the domain of product does not include x equal to 0. So x equal to 0, it has to be basically taken out of the product law, taken out of the domain, I'm sorry. And if we use the product law, we wouldn't get the right answer because of the assumption that is not satisfied. So that's another thing, and so let's do one with the quotient law, basically, and so let's see, if I have the limits of f of x over g of x as x approaches c exists, but neither of the other two limit exists, is that possible or not? So I want to give an example of that, basically, and so give an example of and that could be easy enough. We can choose f of x and g of x both to be x to the power -1, that's 1 over x, and c to be 0. So what is the quotient of these two? It's 1 over x over 1 over x, so I can simplify it to basically 1. But neither of these limits exist. Limit as x approaches 0 of f of x and limit as x approaches 0 of g of x, neither of them exist. So when basically when I'm trying to find the limit through the quotient law, I'm not going to get the right answer because the assumption is not satisfied. But with other methods, I can figure out that this limit actually is equal to 1. And that ends the section.